Thank you very much. Now, honestly, I have to say, now is totally amateur hour, because I don't know very little about airports. I would suggest that, because it's also related, you should just, basically what I'm going to be talking about is like a cruising altitude kind of like view on airports. And we'll talk in particular about kind of like big data strategies in design. And I'm actually super glad with the company that we work. We also do a ton of stuff around kind of like spatial implications of autonomous mobility. So if we want to talk about this later, it's going to be it's very exciting. We Are Certain Measures is a company that is founded 2 years ago by me and my business partner Andrew Witt in Boston or Cambridge, US, and in Berlin. And we are, Lucas mentioned it earlier, we consider ourselves the Office for Design Science. We have a team of architects, people specialized in robotics and computer science and in mathematics. And, Lucas mentioned it as well, I'm trained as an architect. I've done big construction sites working for Geary Technologies, and Geary Technologies was a subsidiary company of Frank Gehry working on basically getting help from the aeronautics industry and in executing his really complex structures, such as, the Louis Vuitton Foundation, which I worked on many years. The problems that we tried to tackle was always like, build a facade out of 20,000 unique facade panels. What kind of like digital and computational strategies do you have in order to execute that kind of complexity? We worked with Frank Gehry, we worked with Jean Nouvel on the Louvre Abu Dhabi, on the Qatar National Museum. So it was never really airports, it was more kind of like big culture buildings with any of these big design architects. Coop Himmelblau, we did the museum Museum of Art and Planning exhibition, Coop Himmelblau. We also did work with you in studio on the Raffles Tower. So we were always these designers or architects with a particular interest in geometry and computer coding. Well, 2 years ago, we founded our own company. I was at the time in New York, leading the team there. My business partner was in Los Angeles and being the director of research. And then we started Certain Measures, and the impulse was essentially to say, let's take the knowledge that we took from Geary Technologies and apply it in our own design company. And so what we do is we work with culture clients. We do kind of like art-related stuff. But we also work with German automotive companies. And for example, one project that we do is exactly similar to what you mentioned earlier. For example, with Audi, we work on actually spatial implications of autonomous mobility. And the little sister of autonomous mobility being autonomous parking. So what's the impact of autonomous parking technology on real estate? But I'm not going to talk about that, and I'm actually glad I don't, because otherwise we would have doubled content. I'm going to talk about kind of like a self-initiated projects that we do. And they are all, not all, but the two of them I want to talk about are in the context of kind of like big data approach in design. One is called Mind the Scrap, and the other one is called kind of spatial recognition, basically applying facial recognition algorithms to the problem of plan reading. And with Mind the Scrap, we had this initial impulse, basically inverting what we have done for Geary, saying you have a design and you ask yourself, where does the material come from? We said, what if we could look at a pile of material and have an algorithm that would suggest the best envelope you can build from it? So now here. So what you see here is actually an installation that we did, and actually on the back end is sort of like technology developed around its very bad graphics, unfortunately. Very bad resolution. So basically saying we start with a pile of material, we scan the material, and we use computer vision algorithm to detect every single element. And then start to compare, analyze first of all every piece of material, and then starting to make sense of them. So make sense of the relation of material pieces to each other. In the third screen, you see these similarity trees. And then in the fourth step, you actually formulate the design intent, and you basically mediate between the pile of material you have, and you try to basically achieve a cube. Okay, so in the end, we presented this at the Haus der Kulturen der Welt in Berlin, and in the end, we created these objects. And you know, when you think about it, it's basically the best cube you could build from an existing pile of material. So we kind of like the irony that freeform is not kind of like is something that you design, but it's the failed attempt to build a cube. So you know. And what I'm saying is, like, I'm suggesting this, I'm basically presenting this material because it was the first time that we worked with kind of what we call morphology analysis. So you analyze every piece of form, and then you essentially create a search engine to find the piece that you need. So this basically, we took this technology and said, like, well, what if we analyzed, instead of analyzing random polygons of waste or scrap material, what if we started to scan cities? So city blocks as the input for the system that we create. And then we start to scan entire cities, organize them, analyze the building plots, and then categorize them. And so the technology that we apply here is, or like the analysis that we apply here is really kind of like a 40-dimensional analysis of each object. To then classify, like basically a weighted analysis, and then to classify them. So you have graph type, so you have maybe I-shaped, L-shaped, U-shaped, G-shaped, C-shaped, or S-shaped polygons. And you essentially scan an entire city and you classify, you don't map the city based on proximity, but you map cities and city blocks based on kind of shape similarity. So we did that, for example, for the city of Tokyo. So it's basically all building plots in the city of Tokyo mapped by shape similarity. And these are really kind of like self-organizing emergent maps. So you scan everything and then you create similarity graphs, and these images or visualization that you see is essentially an unfolded similarity graph. So this is Tokyo, this is London, and you see that, you know, basically the bigger, more squarish building plots on the top bottom left, and on the top right they're more kind of like I-shaped plots. This is, I think, New York. No, this is New York. The one before was Paris. So, but what can we do with these kinds of things? What we essentially, if you know and if you can classify every single object, you can start actually searching for something. Okay. So we developed an interface where we basically take Google Maps or OpenStreetMap. And you can search, it's kind of like a kayak, so the kind of airline search engine, but for city maps. And you can not only search by kind of metadata, so for example, whatever kinds of metadata you can visualize, but you can also draw in the top left corner, you can draw a shape. In this case, you draw basically a very slender I-shaped building. And then on the right, you see how it reorganizes the entire city based on that particular shape. So you have a way to search a city based on building plot types. So if you do something more U-shaped, you will see that it reorganizes the database on the right. If you have something more kind of like X-shaped, it reorganizes all of the building plots based on buildings or building plots based on that shape. And then you can kind of zoom towards that particular shape. And then, obviously, what you can do as well, and this goes back to what you were talking about, if you have access to all of that data, you can start performing analysis on these building plots. So in this case, for example, we were interested in the impact of piloted or autonomous mobility on real estate in Chicago. And we said, look, can we find a way to determine or kind of like extract parking structures from the city plan and do an open space analysis of every single building plot to assess where is basically the biggest potential for redevelopment. So again, we need to do the kind of like shape analysis to make city maps searchable that way, and then you apply just analysis to that database. In this case, it was kind of like impact analysis of autonomous parking technology on real estate. And then we did similar things for interior maps. So using machine vision to make interior maps, and now you could imagine also obviously layout plans of terminals, to apply similar analysis to these. So you scan a map or an interior plan, you start analyzing the circulation through the building, and you basically create analysis around what are the different kind of like room. You sort rooms by size. You create histograms around room distribution and the plan structure and actually circulation structure diagrams. So this is the kind of stuff that we, does it mean it is 10 minutes or I have more 10 minutes? Whatever I want it to be. And obviously at this point where we developed quite a bit of technology, and again, I'm only talking about kind of like the technology we developed around kind of like big data processing. We were asked to give a presentation here. And so we eventually said, okay, well, what if we were to do a kind of like a typology browser for airport terminals, okay? So Lucas also set the tone at the beginning, and he said, look, if we want to talk about the future, what if we were to first of all define what the present is? And when we talk about shaping the future of terminal buildings, what we thought it would be interesting to say, okay, can we look at terminal buildings as a building, or the construction of or designing of terminal buildings as a discipline in itself? Like, can we look at this in totality, okay? So when we talk about, usually in architecture, we always talk about precedents, and then you look at maybe 1, 2, 3, that's the kind of the count that you usually do in presentations. But what if we were to look at 10,000 airport terminals, and what could we draw from it? So we, for the presentation, we thought, let's make this not just a presentation, but kind of like a project in itself, and apply some of the technology that we developed. So we found a database with just geolocation of all terminal buildings in the world, and started to basically started to map them. So first of all, we just pinged Google 10,000 times to create an image database of all airports, which what you see here. Oh yeah, so, and then you can imagine, so now we have basically an image at a particular geolocation on the planet. And this image, and this is basically what we did in a second step, we did a kind of like a chromatic analysis of the image, of all colors in the image, and of then the dominant color in the image, to then say, to make this kind of like a proxy for territory or location. So is it a desert airport? Is it a airport in a city? So what you see, oops, I need to start this one. So you basically start classifying all of the different images based on dominant color, and then start to draw again similarities. So how similar is one airport to another in terms of territory, and then drew basically a color similarity graph of all airports, airports in the world, and how similar we perceive the color in the image, And again, when I'm talking about like what could we do around all airports on the planet, I'm saying, obviously we don't cover everything, but we basically cover a couple of dimensions. In this one, we try to map the territory of all airports. And then this is essentially all airport images organized by color. So you start, and I wish it was a little more granular, or like a little more, the resolution was a little different. So you start to actually, a certain pattern occurs in terms of location where these airports lie. So you have, and I show this to you and also in this view. So this is, oh, no, this one. These are now all airports that are organized based on kind of like terrain similarity, okay? And if we try to come up with what this could be, so we call it kind of like the Aerosphere. So it's like the aerospheric terrain map of all airports in the world. And what you can do in this image, which is the super high resolution image, you can actually start browsing for, let's say, airports in the desert, because you go for basically a particular color, or you say airports in the ocean, and then it takes you to airports that are kind of like on islands, or airports in the Caribbean or something. Or you say like, airports in the mountains, and it will look for kind of like the more whitish colors. I'm actually gonna be done early. Isn't that amazing? Why is that again? Oh yeah. So now I want to go back. So like again, we're basically this presentation is more of a suggestion than a real solution. But so we can start looking at different dimensions of how we can map the discipline of airport terminal design. Okay, in its totality. So again, usually what we do is we look at terminals one by one as precedents. And I want to make maybe one reference here. When you look at, for example, biology, and you are a researcher for bugs, right? You know your discipline. You know there is basically a limited amount of bugs in the world. But when we are architects, the way how we approach a problem is always through precedents. And so what this attempt is suggesting is like, what if we could look at basically at all bugs in the world, right? So bugs being terminal buildings. So usually what we do like, so it's kind of like the typology browser for the discipline, okay? So usually what we do, we look at one terminal, maybe we look at two, maybe we look at four, and we did a very similar approach. We downloaded the images of all airports, then we pinged OpenStreetMap to get the outline of the airport, and then we created a database of all terminal buildings that are related to the airport that you saw earlier, and then started mapping basically a form map of all terminal buildings that we could find in the database. So this is now basically organizing similar to the maps that you saw of Tokyo and London, but not based on a city, like a search engine for form in a city, but it's basically the form map of all terminal buildings in the world. And then obviously there is a similar video that tries to, because it's hard to see from a distance, you see basically, you could also do now all kinds of statistics around how many rectangular terminal buildings there are, or how many, so you see basically all terminal buildings, the shape of all terminal buildings in one database. And I think like the form variety is just astonishing. And I don't know how much that was real design or just basically Terminal 5, or what is it, not Terminal 5, Terminal 4 in London or something. Well, and then, obviously, what we then also started to, we basically tried to get like as many databases that we could, and I'm only showing 2 dimensions, which is basically color and terminal, basically outline of terminal buildings. But then we also started to look at all kinds of performance criteria. So here you see kind of the 30 biggest airport in the US, delays and stuff like this. So we focused on formal criteria, but also looked at kind of like performance criteria of airports and tried to map them as well. Thank you very much.